Saxon Algebra 2, this is a video for Micah. We're going to work through those 4 problems that you gave me today in our video chat saying that they were driving you crazy. So this is the first one on completing the square. Here's what I want you to do. I want you to work through this problem with me. Before I told you to just watch, I changed my mind. That's too boring. I want you to grab paper and pencil right now, or whatever you want to write with. But grab something to write with and copy with me as we go. Then, after we finish this problem, I want you to pause the video and I want you to hide the notes and I want you to try the problem by yourself and see if you can make it work. If you get desperate, dig the notes out and rely on them, but see if you can get through the problem without the notes. Once you do the best that you can to get through it and you successfully complete it, then go back to the video, watch the second problem, take notes on it, pause it when I'm done with that one, hide the notes. You see what I'm saying? Repeat the process after each problem so that you can try the problem immediately after working through it with me, all right? So here is the first problem. This is a problem of completing the square. Write all this down, just like I am, please. All right. The problem is, it's number 9. It says 4x squared minus 3 equals x. No, that's wrong. This should be on this side. Everything should be together. We know we want it to be in this sort of a form. We call it standard form. We want it to look like this before we start the process. So I'm going to subtract x from both sides, right? And then I'll have 4x squared. Now I'm going to put them in order. Minus x minus 3 equals 0. Now I'm ready to begin my completing the square process. That's a problem. I've got a coefficient in front of my x squared. I have an a coefficient that is not 1. It's okay if it's 1 because it's invisible and it doesn't hurt anything. But that 4 is drama. So I have to divide all 4 of these terms by 4. I'm going to do that before I kick it to the curb because that is a big ugly problem and I want it to go away. Now I have x squared minus, now I'm going to change this to minus 1/4 x, right? I'm going to pull that x to the side, put a 1 there because I want to see that fraction really clearly, right? Minus 3/4 equals 0, right? That 4 just goes away. Now we're going to kick that 3/4 to the curb by adding it. So now we'll have x squared minus 1/4 x, empty space, and then positive 3/4 there. Okay, it's looking good. Now we're ready to fill in that gap. What goes there? Oh yeah, magic number. Here is our value for b, the sign and the number. That's what we use to start our magic number calculation. To take the magic number calculation, what we used to do is say take b, divide it by 2, and square it. The same thing is if we say it's b, that's a fraction. Instead, we multiply it by 1/2, okay? And square it. So dividing by 2 and multiplying by 1/2 is the same thing. In our case, we want to use this style. It's minus 1/4 times 1/2 quantity squared. Let's do that multiplication. We draw the arrow because the number inside the parenthesis is important to us. Right? We just multiply here to get the minus 1/8. Now we're going to square it, and that will become positive 1/64. That is what we want to use right here. Plus 1/64, and I'm going to give myself room to fix that fraction. We'll get to that in a minute. Now, this is a trinomial. What I have done is I have created the fraction here that's going to make this into a perfect square. We can factor it into a pair of binomials. I'm doing this the long way. Sometimes I shortcut this process. I'm doing it the long way so to make sure you understand. This trinomial can be written as binomial times binomial, and these two binomials will be exactly the same. That's what we mean by perfect square. That's what we mean when we say we're completing the square. We're creating the same binomial here. And this, what our arrow points at, is what goes in here. Minus 1/8, minus 1/8. We can prove that that's the right answer because these two should multiply to equal that one and add to equal that one. Let's try it. Minus 1/8 times minus 1/8 equals positive 164. If we add them, we get minus 2/8, and that reduces to minus 1/4. So this is correct. Now, because those are the same, we can write them, we can write them in this style, right? Instead of writing them separately, we can write them as 1 squared. And that will make it easier for the step that's coming up in just a minute. Okay, so this is super important work. This is what we mean by completing the square. In the meantime, we need to add the magic number to, no, this is the magic number. We need to add it we need to add it to what was already over here. We're going to have to fix that denominator. I believe it is 16/16, isn't it? Right, because that gives me 64. And then up here, I will have what, 48/64. So I've fixed my 3/4 so that the denominators match. And now I can write that total here. It's 49/64. That's a cute and interesting number, isn't it? All right, so now things are looking really good. We're ready. Our job is to isolate x, of course. So now what we can do is take the square root because the squaring and the square rooting will cancel each other. Then I have to do it over there. This now becomes nice and neat. X minus 1/8, that all cancels, equals. Now because we're taking the square root here, we have to say plus and minus. And that becomes what? 7/8. So nice, right? And now we are ready to, let's see, we've almost got x by itself. We need to add 1/8. That cancels. X equals 1/8 plus or minus 7/8. Now, these are just nice little fractions with even matching denominators. No radicals, no complex numbers. There's nothing creepy in here. So we can actually do that. That gives us two values. 1/8 plus 7/8 equals 8/8, which equals 1. That's if we add them. Now what if we subtract them? 1/8 minus 7/8 equals minus 6/8, which equals minus 3/4. So the final answer for this is x equals 1. That's what we got when we added them. And minus 3/4, that's what we got when we subtracted. Right? Remember, that's what this sign means. It means added or subtracted. Let me double check. 60.9. Yes, that's the right answer. Yay. Okay. Make sure you wrote all that down with me. I hope you paused me if I was going too fast. I really did go kind of fast, didn't I? And that was a lot of writing. But now you've gone through it. The important things were to reorder it, to divide the 4 away, to kick it to the curb, kick this C term to the curb, magic number calculation, rewriting this as a perfect square, fixing the fraction over there, and then some little algebra at the end to give us our 2 different answers, one by adding and one by subtracting, right? Okay, what I want you to do now is pause me, hide the notes, and try this problem again while it's still fresh in your mind. If you need to use the notes, you can look at them, but please give it a fair shot with the notes hidden first, okay? Then when you've tried it and finally successfully completed it, hopefully without the notes, but in case of desperation with the notes, then you can come back and we'll look at the next problem. Okay, so I'll see you in a few minutes. Okay, I'm assuming you are back now. I didn't see you go. But now we're gonna try homework problem 62.9. Let me just flip in my book. I've got books all over the table. I look like I'm on some mad study kick, which I suppose I am. 62.9 is another completing the square problem. So what I'm going to do is copy it and help you get started, and then I want you to try it by yourself. Minus x plus 2x squared plus 3 equals 0. Okay, 62.9. Yes. All right, now this is still drama, but at least everything is on the left side, right? And we've got the right side set to 0, but they're not in the right order because I want them like this, right? So we just have to rearrange things. The 2x squared should be first, then the minus x, then the plus 3. Okay, so I wasn't swimming anything across the equal sign, I was just rearranging, and that's fine. All right, so we see, look, there's a lead coefficient of 2. That's not happening. So we're going to divide everything by 2. And then we'll get x squared minus, and then again, I don't want the x to be part of the fraction, so it becomes minus 1/2 x plus 3 over 2 equals 0. And then I'm going to kick that to the curb. X squared minus 1/2 x equals minus 3/2, right? Because I subtract 3/2 from both sides, right? Okay, this, my friend, should give you enough of a head start so that you can finish this problem on your own. The steps are exactly like the last one. I got you through the harder part at the beginning to get it all cleaned up, but now you've got a gap here, and you know what goes in the gap, and you know how to calculate it. I gave you the formula, and then you can, if you really get stuck, you can refer to your other notes to see how to do that. But what I want you to do now is pause me and hide this paper and start this problem, 62.9, from the beginning and try to work it all the way through yourself. While you're gone, I'm going to go ahead and complete this problem so that you have that information if you need it. But I want you to try the problem without looking at this. Actually, you know what I'm going to do? I'm going to send you a picture of this later. I'm not going to do it in the video because you should be able to do that by yourself. We just went through it, and I got you through the hard part. All right, so I will send you photographs of these problems after we're done with the video, and I'll finish this one. All right, so pause me and try 62.9. Okay, you're back. I hope that went well. The next problem is 62.7. Okay, I'm doing these in the order that I thought made the most sense. Okay, so I did the 2 completing the square problems together. Now we're going to do a problem on taking the rectangular coordinates and moving them into polar coordinates. Remember, these are 2 ways of saying the same thing. So we're translating just as one might translate in language, all right? We're just translating from one system of notation to another, all right? What's the problem? 62.7, convert minus 2r plus 5u to polar form. Okay, so the very first thing we want to do is draw the picture. So we start thinking about it. I'll just draw the whole grid out rather than zeroing in. minus 2 to the right. Okay, that means we're going to be going this way, 2, and positive 5 up. 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. I'm not going to number all those. Now, let me be clear on how we do this. Once we identify the distance on this axis and the distance on this axis, we put a dot at where they intercept, just like our old school graphing, right? This is just like rookie graphing. Then we draw a line from the dot to the x-axis, or the right axis, however you want to think of it. And then we draw a hypotenuse to the origin, okay? I've seen some students get really confused on what you're supposed to do here. Measure this distance and that distance, locate the point, and then draw down and to the origin. We always orient the triangle to this axis, never this one, okay? So always draw it down or up if you're down here, right? Okay, this is a right triangle, and we know by this address, if you will, that this side must be 5 units, right? Because it was 5 up, and this side must be 2. Even though it's to the negative side, that doesn't matter for our purposes right now because we are trying to just look at this triangle. Now, we want to write this as a polar coordinate. Polar coordinates look like this. They have a number here, and then they have this weird box thing, and there's another number in there. This one is the angle, or sometimes we call it the direction. We start measuring it here, and we're going to want it to come back and end. I'm just going to draw it. The angle is going to tell us how far to go like that, right? And then this is the distance or the hypotenuse. Squeezing it in, right? So we're going to have to figure out how long that is, all right? Let's do the hypotenuse first. Let's just go in order, which is, you can do it in either order. It doesn't matter. There are a couple different ways to get the hypotenuse, but the easiest way is Pythagorean Theorem. So let me just write this down. We're going to work on the hypotenuse first. And we're going to use a squared plus b squared equals c squared. Okay. We know that a and b have to be the legs, and these two are the legs. So we know that 5 squared plus 2 squared equals c squared. We'll just call that c. We could call it h for hypotenuse. We could call it h for hammy. We could call it f for fun. It doesn't matter. Make up your own system. Okay, 5 squared is 25. 2 squared is 4. So that equals c squared. And then when we add it, we get what, 29? And then we'll need the square root, right? So c, I'm going to reverse the order, c equals the square root of 29. Okay? We don't need to consider the negative because we can see that's a positive length. All right, 62. I'm flipping to the answer to make sure that I'm on track. Because the last thing you need is me confusing you further. That would be completely unhelpful, wouldn't it? Yes, that's correct. So our hypotenuse equals the square root of 29, and that's what goes right here. Yay, we're half done. Now we need to work on finding the angle. We need to know what this angle is. Notice that this angle isn't what goes in the box. We want this, right? But if we can figure this out, that will help us figure the rest out, okay? So sometimes the angle that you find just leads you to your answer. It doesn't actually serve as the answer itself. Now, we want to use our trig functions, and we know that we've got an adjacent side of 2 and an opposite side of 5. So what trig function can we use to find this angle if the two pieces we have are the opposite and the adjacent? Well, opposite over adjacent is tangent, right? And our opposite is 5, and our adjacent is 2. Which means if you grab a scientific calculator, we can find this. And here's what you need to enter. You need to go 5 divided by 2 equals, right? These are all separate buttons. And you should get, it'll be 0.5, won't it? 2.5, sorry. Right? It doesn't even matter. Then what you want to do is you want to take that, your 2.5, and then you want to go second, right, to get the second set of keys. And then you want to go, it's called inverse tangent, but it looks like that. You want to hit that, and then you want to go equals, and what you will get is 68.20 degrees. What we did was we used the actual ratio, what turned out to be a decimal number. We used the decimal number to get the degrees of this angle, 68.20. That is rounded, I'm sure, okay? So that's how big this angle is. But this number does not belong in this box. What belongs in this box is this number. So we have to figure out how to use theta. That's what this one is, that loopy O thing. We have to figure out how to use this to come up with that number. And the trick is to see that, oh, if that's added to theta, that becomes the whole 180. So if we take 180 degrees, which is the whole thing, and we subtract 68.20, then we'll get the part that we want. And so then that becomes, I'm just subtracting here. And what we learn is that 111.8 degrees is that angle. That's what belongs up in the box. This theta that we found by using tangent, that just allows us to do one more calculation, right? We have to subtract this from 180 in order to get that part. All right, so now we found that one and we found that one. That is our final answer and we are done. Okay. Breathe. Pause this. Go to hide this paper, grab your homework, and try this problem again without looking at my notes. If you get completely overwhelmed and stuck, then you can flip my notes back over, these notes back over. They're your notes of this problem. Then you have the answer in front of you, but try it right now before you forget a single thing I told you, okay? Come back when you're done. All right, one more problem. This is homework 61.11. This is the experimental data. And I'm going to change the way we do these problems from now on. What I'm going to do is I'm going to tell you what the 2 points are that I want you to use. They will not be exactly the same as John's, but it will be, I will tell you what to do, and then I will show you the answer. You'll use my solutions for these and not John's. Let me show you in the book what's happening. It's one of these fuzzy dot problems, right? We're scientists. I hope you have your lab coat on. I've got mine on. I've got my safety goggles on because you never know when we might have a chemical spill, right? So we have to be very careful. 6111 was the one in particular. 6211 is another version of the same. All right. These data points come from an experiment involving lead, there's the abbreviation, and and antimony. I don't know what that is. Okay, so antimony and lead. So we know we're starting with antimony because it's always on the x-axis what we start with, and then what we end up with is over here. Write an equation that expresses lead as a function of antimony. Okay, that just means lead is the y and antimony is the x. We already knew that. And they're giving us, instead of y equals mx plus b, look, he just put in the chemicals for us. That was nice. Now, the hard part of this is finding the points. So I'm going to tell you which points to use. I'm going to tell you to use this point and this point. They are not exact, but with experimental data, we're not trying to be 100% precise. We're looking for patterns. So the points that I want you to use for this problem are 1 and 10. Make sure you write these down. And 1.5 and 30. Let's double check and make sure those are right. This way. 1 and 10. Yeah, that looks pretty good right there. 1.5 and 30. That one's decent, okay? We're going to use those, and now the whole problem is going to be a breeze. I will work through it just to show you how easy it is, but you should be able to do this. The first thing we want to do is find the slope. The way we do that is we use slope formula, which is y2 minus y1 over x2 minus x1. We will name these x1, y1, x2, y2. There are no minuses in here, so I'm not going to worry about buckets. It's 30 minus 10 over 1.5 minus 1. Okay, I filled those in. Now I'm going to do the math. 20 over 0.5, so we get m equals 40. Okay, so that is the slope of this line. We're approximating it to be 40. If you look in the solutions manual, it says, just a second, I'm looking in the wrong lesson. 6111. John says 42.6. Well, ours is close, so that's fine, okay? So from now on, you don't have to look in the solutions manual. I'm going to give you solutions for these problems, so this is the right answer. Now we're ready to plug it in, and I'm just going to use the chemical abbreviation since John already put them in for us. PB equals M times SB plus B. Okay, I'm going to put parentheses around the ones that we're trying to figure out. These are just the chemical symbols, and we're using them to substitute for X and Y. It doesn't make the problem harder. If that makes you just crazy, put a Y there and an X there, and we'll substitute those in at the end. That's fine. Now, we know that the slope is 40, and what we do is we need to pick one of our points to go in for these two, right? Well, I'm definitely going to pick this point because I like these numbers better than these. So I'm going to say 10 equals, and then our slope is 40, times X is 1 plus B. Okay? And then 40 times 1 is 40. I'm trying to isolate the B, so let's subtract 40 from both sides. That all cancels, and we get minus 30 equals B. Okay? Now I'm ready to put it all together. This is the form, so I'm going to write PB equals 40SB minus 30. That is my answer. That is the answer I want you to get. Just for yucks, we can look at John's answer. Just for yucks. Oh my God, what kind of thing was that to say? John's answer is very close. He has 42 and some decimal points minus 32. Ours is better. This is the answer I want you to get. From now on, I will give you the solutions to these problems so that you don't have to torture yourself, all right? So I will send you the solutions for I will tell you which points to use for these problems, and then I will give you the solution, all right? So I will say use these points, because otherwise it's too hard to figure out what John's doing, and your answer is always going to be different than his. Okay, so pause me, work this problem, and then come back for a final few words from me. All right, remember, hide this, try to work the problem, copy down the point first before you hide your notes. Copy down this point, hide the notes, try to work it through, get this. If you absolutely desperately need to, pull this back out, but try to do it without, okay? And then come back and talk to me. Okay, we've now worked through the 4 problems. You have notes on how to complete them. I'm also going to email you pictures of these because it's a lot easier if you're trying to double check your work. It's a lot easier to look at the picture than it is to look at the video and freeze it. I know that's not always easy. So you have everything you need to successfully complete these 4 problems, I hope. What I want you to do right now, because you've worked all 4, I want you to message me back and tell me how this worked for you. All right? I want to hear from you as soon as you can, because I'm thinking about what else I can do to help you understand. All right. So here's your final message. All right? Yay! All right, good luck. Bye.